Hello students, today we are going to start with chapter 9, that is light reflection and refraction. Actually this video will be a revision video for this chapter where we are going to discuss important topics from this chapter, and I am going to prepare a separate video for the detailed explanation of this chapter also. So in this video we are going to study very important topics and the topics which will be asked for exams, even the problems or the formulas, the diagrams which are important for exam, which you can see in a very quick way. So those all points we are going to cover in this video. So we are going to start with the definition of what is reflection. Let's start. So as I told, it is a revision video for this chapter, that is light reflection and refraction. So directly going to move with a definition. So first we are going to see the definition of reflection. So what is reflection? Reflection of light is when light rays hit a surface and bounce back into the same medium. So I hope you are understanding, when light hit to a surface and if it bounce back into the same medium, then the process is called as reflection. So if suppose this is a surface and this is the light which is going to hit on the surface. Once it hit, it bounce back into the same medium. So this is medium 1 and this is medium 2. If the light is coming from this side, medium 1, and if after hitting, if it goes back into the same medium, that is medium 1, then the process is called as reflection. Now we will see laws of reflection. So this reflection follows some law. So there are two laws which we are going to study in this chapter. So first law says the normal, the incident and the reflected ray all lie in the same plane. So if you see this diagram, this is called as an incident ray which is going to fall or which is going to hit on the surface. This is called as a reflected ray, which is a ray goes back into the same medium after hitting the surface. When it goes back into the same medium, that is called as reflected ray. And the normal will be drawn at the point of incidence. If this is the point of incidence, then here we are going to draw one perpendicular line like this, and this is called as a normal. So here the incident ray, the normal and the reflected ray all will lie in the same plane. No rays will come out of this plane or out of the screen, in front of the screen. If it is coming out of the plane, then this law will not follow. So all the lines, all the rays should lie in the same plane. So that is our first law. Now the second law is angle of incidence is equal to the angle of reflection. So if you see this diagram, this incident ray and the normal is going to make this angle, which is called as angle of incidence, and this reflected ray and this normal is going to make one more angle, which is called as angle of reflection. This is angle of incidence and this is angle of reflection, or you can say incident angle and reflection angle. This both the angle should be always equal. That is our second law. So this is angle of incidence, which is denoted by the letter I. This is angle of reflection, which is denoted by the letter R. Both should be always equal. So remember, if this angle is 30, then the reflected angle must be 30. So imagine if your incident angle increases. Imagine the line is coming from here. So see, the angle of incident has been increased. Imagine if it is 60, then the angle of reflection will also increase. So this is the angle of, this is the reflected ray and this is the angle of reflection, and this will also becomes 60. If the angle of incidence still increase like this, if this is the incident ray, then the reflected ray will come here. So see, the angle of incident also increasing and the angle of reflection also increasing. So that is our second law. The angle of incidence is equal to the angle of reflection. So after finishing these laws of reflection, now we are going to move with concave mirror. So before concave mirror, in our detailed video, you will study simple mirrors, plane mirrors. We are going to see what is plane mirror and the characteristics of the plane mirror. And now here, as I told, it is a revision video of this chapter. We are going to directly move with the concave mirror, its definition and its diagram. Stay connected with me, like my videos, share my videos to all your friends, and even consider subscribing my channel. It will help me to prepare more and more videos for you all. Now, we'll start with concave mirror. So what is concave mirror? Curved inward and converged light forming magnified, that is real or virtual images. So whatever diagram you can see, it is the diagram of concave mirror. So this is a concave mirror. So if you see this concave mirror, whatever portion here you can see inside, this is the dark line which you can see here, it is a shining surface or the reflecting surface of this mirror. So this surface is curved inwards. See here, it is curving inside. So it is a concave mirror, and when the light falls on this surface, this you can see, these all parallel are the light rays. So when this light falls on this shining surface or the reflective surface, they will go hit the surface and bounce back into the same medium. So you can see all the rays. Even if I see this ray, it goes, hits and goes back into the same medium. So like this, when the light falls or hits on the shining surface of this concave mirror, or I can say reflecting surface of this concave mirror, all will converge at one point. What do you mean by converge? Converge means they all will meet at one point. Such mirror is called as concave mirror. And even whatever image will be formed in this mirror, it may be real or it may be virtual. Why it may be real and virtual? This is depend on the position of the object. These all things we are going to study in detail in our next pages. So depending on the position of this object, our image, it may be real or it may be virtual. So this is about concave mirror. Now see what is convex mirror. So it is opposite of concave mirror. It curves outward and diverge light. So you can see this diagram. So this is our convex mirror. If you focus on this convex mirror, there is one dark line which you can see here. See, this is the dark line and which is curved outward. Here it is inward, it is going inside like this, and in convex mirror, that shining surface or the reflecting surface, it is curved outward like this. So here the light rays which are coming parallel to this to each other, these all the light rays when they comes and hit on the shining surface, they reflect into the same medium like this. See the another ray, it goes, hits and reflect in the same medium. So when these all the rays goes and hit on the surface and reflects in the same medium, these all will diverge. Diverge means they will go far away from each other. In case of concave mirror, they will all converge, they will meet on one point. But in convex mirror, after hitting, they will diverge, they all will go away from each other. And this is what happens in case of concave mirror. What about image? So here, always forming smaller, the image will be always smaller. It may be virtual and the image will be virtual and upright. Always remember the image will be smaller, virtual and upright. So this is about convex mirror. I hope you understood what is convex mirror and what is concave mirror. It is important to remember this definition. Sometimes in exam they will ask what is convex and what is concave mirror, and sometimes they will ask write the differences between convex mirror and concave mirror. If you remember these points, you can write it separately if they ask the differences. Or if they ask definitions, just write this one sentence as definition. So I hope you understood. Now we'll move with the next page. Now here we are going to study summary of image formation by concave mirror. Before going to the summary, actually we have to study some rules of image formation. How the light, when the light comes and hits the mirror, how it reflects and where the image can form. These all rules have been given in our NCERT book. So those all we will study in our detailed video. Now we are going to move directly with the summary of image formation by concave mirror. This is a very important topic. Many of the times in exam, these diagrams will be asked. It may be of concave mirrors or it may be of lenses, but one diagram will be compulsory. So now we are going to move with this diagram. So here I have prepared one table, and same like this table is there in your NCERT book also. You can refer that table also. In that table, everything is given in a shortcut way. After studying each and every point, you will understand immediately how the image and where the image will be formed. So without wasting much time, we'll start with the first one. So focus on the first point. Here in this table, you can see the headings. First it is serial number, then second I have written object location, where is our object located, then where we are going to get the image, that is image location, then how the image will be, what is the nature of image, it may be real, inverted, virtual, etc. Then we are going to see the size, image size. So these are the main thing which will be asked in our exam. What is the nature of the image, what is the size of the image, and what is the location of the image. So if you see these points, we can easily draw the diagram. You have to just remember this table. Now we will start with the first one. So serial number 1, when our object is at infinity. And one more thing, remember students, this all is about only concave mirrors. For concave mirrors, we have total 6 diagrams. But for convex mirror, we have only two diagrams. So now start the first one. When we keep our object at infinity, then our image location will be at F, that is focus, principal focus. And the nature of the image will be real and inverted. The size of the image is highly diminished. Highly diminished means it will be so small, like it will be a point-sized image. So see the first diagram here. If you see the diagram, this is our concave mirror. Inward, this all inward area is our reflecting surface, and this is our principal axis. Then here, this AB, this is our object. Remember, this is our object. So this object is placed at infinity. It is not connected with any of these lines. So it is said that it is at infinity. So when it is at infinity, all the light rays will be parallel to the principal axis. So I told this is our principal axis. Center is our principal axis. Then the first ray and the bottom ray all are parallel to each other. And like this, many rays will come and hit on the surface of this concave mirror. When they hit, all will get reflected, bounce back into the same medium, and because all are parallel, all will come and converge at this point. So see this point, it is directly on the principal axis, and therefore our image is nothing but this point. And therefore what I have written, the image location is at F. So this is our F. You can see here, this is principal focus at F. And what is the nature? It is real. Here the image is formed at the same side from where the light rays are coming. The image is on the same side where is our object, and therefore the image is real. Always, whenever it will be on the same side, it will be inverted. Therefore, nature is real and inverted. What about the size? Just now I told the size is point size or diminished. So write down highly diminished. Now we are going to move this object towards the mirror. So second one, when our object is beyond C. Beyond C means this is our C, center of curvature. Beyond C means behind C, somewhere here. Now see the second diagram. So this is our C, and now our object is beyond C, which I have drawn on the principal axis. Now you can see here, this is the difference. Here there is no connection between the object and these lines, but here our object is on the principal axis, which is behind, backside of this C. Whenever our object will be beyond C or behind C, some rays will be parallel and some rays will pass from the center of curvature. Always remember, so here we have to draw two lines. One line should be straight, parallel, and one line it should pass from the C, that is center of curvature. Both will go and hit on the surface of this concave mirror and bounce back. The ray which is going parallel, it bounce back, pass from the focus. The ray which is going from center of curvature, it goes straight and comes back on the same way. And therefore both the reflected rays will meet at this point. So from this point we are going to draw a straight line to the principal axis, and this is our image. So here you can see this is our image. So if AB is our object, then A dash B dash is our image. So what we can write here? So where is our image? What is the location? It is between C, center of curvature, and F, principal focus. So write down the image location is between C and F. It is real and inverted. You can see it is on the same side where the object is, and therefore it is real. And you can see if it is on the same side, it will be inverted. So here A is up and here A dash is down, so it is inverted. What about the size? It is not same as our object, and it is not greater than our object. It is smaller than our object, and therefore we will write diminished compared to the object. Now move to the third one. Now we are going to move our object again little bit towards the mirror. Now our object will be kept on C, that is center of curvature. Now see the third diagram. Now object AB, it is on C, center of curvature. Here also if you see, some light rays will be parallel, some light rays will pass from the principal focus. The ray which goes parallel pass from the focus, and the ray which goes from the principal focus, which reflects and goes parallel. And if you see, both the reflected rays will come and meet at A dash. Here is this A dash. From this point, if you draw a perpendicular light on the principal axis, then this is our image, that is A dash and B dash. This is exactly below the C. It is exactly on the C. Sorry, below the object and on the C. If you see the size of the object and the size of the image, both are exactly same. It is on the same side. So I hope you understood now what to write. So what is the location of the image? The location is at C. It is real, it is inverted, and it is same side. Many of the times this diagram will be asked, so remember same size. Now we'll move with the fourth diagram. Now we are going to keep our object between C and F. So little bit we are going to move towards the mirror. So now our object will be between C and F. See the next diagram. Here it is. So this is C, this is F, and here our object. So as the object moves towards the mirror, it will be small object. See the size, it will be small. So this is our object. Now the light ray which goes parallel pass from the focus, and the ray which pass from center of curvature which goes back in the same line, and both will come and meet at A dash. So draw the perpendicular line towards the principal axis. So A dash, B dash, this is our image. Now what is the size? What is the location? Here the location is, it is behind the C. See here, it is on the principal axis but behind the C. So we will write beyond or behind C. It is on the same side. So it is real. So it is inverted. And if you compare the size, this is our object and this is our image. See, you can compare the size. It is a little bit big than the object. Therefore, I'll write enlarge. So from here, our image is going to be enlarged. So what it shows that as we move towards the mirror, our image size will be go on increasing. Now we'll move the next one, that is fifth one. Now, after this, we are going to keep our object at F. So when we keep our object at F, the rays after reflecting, see here, they will go and meet somewhere far, and wherever they will meet, from there we are going to draw the perpendicular line to the principal axis. So somewhere far our image is going to form, and this position is not on the lines. So it is called as infinity. Therefore, we will write when our object is at F, principal focus, the image location will be infinity. On the same side, therefore, it is real, and if it is real, it will be inverted. It will be going to be so big, it will be bigger than our object, and therefore it is enlarged. And now we are going to move with our last one, that is sixth diagram. Our object will be between principal focus and the pole. See here, this is the last diagram. When the object will be very near to the mirror, our image, see the reflected rays, when the rays which is going from this uh, object, it passes from, goes and hits on the pole and bounce back into the same media. See here. So here angle of incidence, this is angle of incidence. So it goes, hits and goes back into the same media. And some rays which are going to pass from the center of curvature is goes back into the same line like this way. And on the same side of the light rays, they will never meet. This is one reflected ray, this is another reflected ray. So they will never meet on the same side of the lens from where the light rays are coming. So now what to do? So we will try to join these all the lines behind the mirror. So when we extend these lines behind the mirror, somewhere here they will come and meet. And therefore our image may be formed back side of the concave mirror. So this is our image. It appears to form here A dash and B dash. Whenever our image is formed backside, opposite side of the mirror, then it will be always virtual. Remember, it will not be real, it will be virtual. And if it is virtual, it will be erect. See, this is our object. Same like that, our image is. So it is erect. But in earlier, all the diagram, if you see, our image is inverse. It is reverse. That is called invert. But here our object image is erect. Therefore, we can write whenever the object is between F and P, the image location will be behind the mirror, backside of the mirror. It will be virtual, it will be erect, and it will be enlarged. It will be very big compared to our object. So these all the diagrams which will be formed in case of concave mirror. So always remember, prepare one by one. You keep your object at infinity, then go slowly towards the mirror. As we move towards the mirror, our image will go away from the mirror. This is the main trick which you have to remember whenever you draw the diagram. So remember, whenever your object is far from the mirror, your image will be near to the mirror. Whenever your object is near to the mirror, your image will be far from the mirror. So this is the trick which you have to remember. So I hope you have understood, and I hope I have helped you to understand this all the diagram. Practice this diagram because these are very important. Now we'll move next. Now we are going to move with summary of image formation by convex mirror. Convex mirror, it is a mirror which is curved outwards. So here, as I told, we are going to see only two diagrams. So this is the table from your NCERT book. I hope you remember this table, which is very, very important. Instead of reading whole sentences, it is easy to remember the summary in the form of table or diagrams. So first one, whenever our object is at infinity, as I told, all the rays will be parallel. See this, all the rays will be parallel. They will hit on the reflecting surface, and as it is a convex mirror, the rays will diverge. And whenever they will diverge on the same side of the mirror, they will never meet. There will be no possibility to meet these all the reflected rays. Then what we are going to do, we are going to extend this line behind the mirror, back side of the mirror, and somewhere here they are going to meet. This is called as focus, principal focus. So in first diagram, our image is going to form at focus. So here it will be of point size. Therefore, image location at focus behind the mirror. Remember, it is highly diminished. Highly diminished means how much? It will be of point sized. And what is the image size here? Image size is point size highly diminished. Sorry, here we have to write image nature. By mistake, I wrote two times, that is image size. So what is the image nature here? So here it should be virtual and erect. So I will write it here. By mistake, I kept it same. So it will be virtual and erect. So this is the image nature. So if you focus the diagrams, the light rays are coming from this side, but our image is going to form on the other side, opposite side of the mirror, and that's why it will be always virtual. And if it is virtual, then it should be erect. Now the second diagram, we are going to move our object towards the mirror. So earlier it was at infinity. Now when it comes towards the mirror, we are going to keep it AB here. If you see this, between pole and the infinity. So this is somewhere here infinity. This is our pole. So in between these we are going to keep. So this is here our object. When you keep your object here, the light rays, parallel lines goes, hits and diverge. The ray which is going to pass, by keeping in a mind that is center of curvature, it goes in a straight line. Then when we extend it, when we extend these lines on the back side, see here, when we extend this ray, it will come like this. When we extend this ray, it will goes like this, and both will meet somewhere here. From here, if I draw a perpendicular line on the principal axis, then this is our image location. So image location is where you can see this. This is the small one, A dash, B dash. This is our image, and this is our object. So here also we can write the image location is between P and F1. What is P? P is pole, and here F means what? That is the focus. Always remember, in convex mirror, our focus will be behind the mirror. So this is our focus. So between P and F, there will be our image. What about the nature? Nature is nothing but again same. It should be virtual and erect. So don't see this. So I will put one line on this so that you should not get confused. So I'll write it here also. This is also. So here also what you have to write? We have to write virtual and erect. So I will write it virtual and erect. So remember this. So this is also virtual and erect. And what about the size? Size is diminished. What do you mean by diminished? It is nothing but smaller than our object. So object is here. If you compare our object, our image is smaller. So these are the two diagrams of convex mirror. So in concave mirror, our image, there were 6 images, 6 diagrams, 5 diagrams where our image was real and inverted. But 6th diagram was having virtual and erect. But in case of convex mirror, we have 2 diagrams, and in both the diagrams, our image nature is virtual and erect. So you can see here virtual and erect. So these are the 2 diagrams which you have to remember. At least this diagram you keep it in mind, which is very important. Many of the times it will be asked, if you ask me about convex mirror, then this is the important diagram. Now we are going to move with uses of concave mirror and convex mirror. This you can write in your differences also. If the differences is asked of concave mirror and convex mirror, then one of the difference you can write as uses. So what are the uses of concave mirror? As I told, we have seen 6 diagrams in concave mirror, means concave mirror has many uses compared to convex mirror. So the first use is torches. You can use it searchlights. We can use it in a vehicle headlights. We can use it in a dentist. In case of dentist, those will use this mirror to see the small object in a bigger way. So fifth use is large concave mirrors are used in solar furnaces. So these are some uses of concave mirror, remember. And for convex mirror, very important, only one use, that is used in rear view mirror in vehicles, which is very important. As I told, it has only two diagrams, but the application of this convex mirror is very important, very big, which is used in rear view mirrors in vehicles. The mirrors which will be there in our bikes or the cars, beside there will be two mirrors, side there will be two mirrors. So these mirrors which are used to see the behind backside vehicles which are coming from us, backside our vehicle, with the help of that we can overtake the vehicle which is in front of us. So we can cover a large area from the backside in that small mirror, and that is the main use of this concave mirror. So remember this, it is only one, but it is very important. So this is the summary of convex mirror and concave mirror. Now we will move with next. Now the important concept of this chapter, that is the numerical part or the formula part, which is very important. So remember this, the new Cartesian sign convention for spherical mirror. So especially in this chapter, whatever sums will be there, those all will be in the form of sentences. They will not give directly values in plus and minus sign. They will give the sums or the numericals in the form of sentence. We have to read those sentences and we have to understand where is our object, where is our image, and depending on that position we have to decide the signs, that is positive or negative. And for that this diagram will help. This is the diagram from again your NCERT book. So if you remember this diagram, only two things you have to remember. Only remember these two things. You can easily solve all the sums because there are no much formulas in this chapter. We are going to study the formulas here. So first we will see what is the sign convention. So this is our mirror, concave mirror. Then if this, actually in this diagram they have given the concave mirror, but the same thing will be applied for convex mirror and even for the lenses. So if this is the mirror, that is M and N, and this is the principal axis, that is X and X dash, and this AB, you can see here, this AB is our object, A dash B dash is our image, P is our pole. Then whatever distances are towards the left from this mirror. So if this is mirror, then this is left side. So from mirror, whatever distances you are going to measure towards the left, all should be negative. Remember this. And whatever distances you are going to measure towards the right of this mirror, all should be positive. So here this side all should be positive and this side all should be negative. So I'll just write this side is our left. Here I'll write it, sorry, I'll write it here right. It will help you to remember. So whatever distance you're going to measure on left side, it may be a object distance or it may be a image distance, all should be negative. Whatever distance you're going to measure on the right side, object or image, it will be in a positive side. Whatever heights you are going to measure upward, what is upward? Above the principal axis. This is principal axis and this is the upward height. All should be positive. Whatever heights you are going to measure below, see, this is principal axis, this is below. So whatever heights you are going to measure below the principal axis, all should be negative. So these are the main things which you are going to remember. Always remember, once again I will repeat, if this is our mirror, then this will be left side, this is the right side. Whatever distance is on the left side, negative. Whatever distance on the right side, positive. If this is the principal axis, whatever heights on the above principal axis, positive. The distance below principal axis, all should be negative. Now whenever sums are coming into the exams, you have to read the sum and understand the sum. Where is your image located, where is your object is located, and depending on that you have to decide negative or positive sign should be given to that value, because these signs will not be given in your sums. So this diagram will help you to understand the sign convention for mirrors as well as for the lenses. And remember, this is the same way we are going to use for even convex mirrors. So now we are going to move with mirror equation. So this is the equation which you are going to use for the numerical solving, which is called mirror equation. What is mirror equation or what is mirror formula? Sometimes like this question also will be asked. So this is the equation actually, which is called as mirror equation. 1 by V plus 1 by U is equals to 1 by F. So what is V, U and F here? U is object distance, nothing but the distance from object to mirror. V is image distance, the distance from image to mirror. and f is focal length. It is the distance from the principal focus to the mirror. So these are the letters which are used in this mirror equation. So what is mirror formula or mirror equation? It is the equation which gives the relation between object distance, image distance and focal length. So like this definition also you can write if the question comes, what is mirror equation or what is mirror formula. Now here remember these all the three letters. Always remember one more thing, focal length. For concave mirror, your focal length will be always negative. I hope you remember this. If you recall, this is our concave mirror and this is our principal axis. Whenever the light rays comes parallel, they will hit and reflect. They will hit and reflect. So this is our principal focus. And this is the principal focus which is written as capital F. The distance between this principal focus and the pole which is here. So this is on the same side of the mirror. It is on the left side. You can see this. If this is on the left side, this will be always negative. And in case of convex mirror, our mirror is like this. This is our principal focus. Now whatever the rays are coming parallel like this, they will not converge. They will diverge like this. Like this they will diverge. So where they are going to meet? So we have to extend this backside like this, and somewhere here they are going to meet. This is principal focus, this is pole and this is the distance. This is on the right side. So this will be always positive and here this will be always negative. So same thing I have written here. It is very important you should remember these signs because focal length you should remember. Focal length for concave mirror negative, focal length for convex mirror positive. Then object distance is negative for both concave or convex mirror. If we recall all the diagrams, whatever object we had kept, it was on the left side of the mirror. So it was always negative. But what about image distance? Image distance may be positive or it may be negative. For convex mirror, it will be always positive because there are two images in case of convex mirror, and in both the images, if you see, our image will be behind or backside of your mirror, somewhere here, backside, and therefore in this convex mirror, it will be always positive. But in case of concave mirror, total there are 6 diagrams. So out of 6, for 5 diagrams, our image distance or the image formation will be on the same side, and for only one diagram, it will be behind the mirror. Therefore, image distance, it may be positive, it may be negative, it is depending on position of your object. So remember this, these are the hints which you have to remember before solving any sum in case of this chapter. Now the next which is asked, that is magnification. Magnification means how big your image has been formed compared to your object. That is called as magnification. Magnify means making it big. So what is the symbol for this? It is small m. So as I told, how big your image is formed compared to your object. So we are going to compare the height of image and height of object. And therefore the formula is m is equals to h dash divided by h. What is h dash? H dash is nothing but height of the image. And h is nothing but height of the object. For magnification, we can use also this formula in terms of V and U, that is image distance and object distance. Also, we can find out magnification, and this is the formula for image and in the form of image distance and object distance. Then, the important thing which is asked in after finding out magnification, it is asked that the image is virtual or the erect. So, you should remember whenever your magnification value is negative, then your image will be virtual behind the mirror. Whenever your magnification will be positive, then the image will be always erect. So remember this hint. Sometimes value will be given and you have to find out it is virtual or erect. So in those cases, it will help you. Only 2 sentences we have. If you remember this, it will be easy to answer the values. In case of multiple choice question, it may be asked. So remember, if magnification value is negative, the image is virtual. If magnification image is positive, then the image is erect. So this is about the equations of mirrors or the formulas of the mirrors. So these all things are the revision of mirrors, that is concave mirror and convex mirror. After this, we are going to move with lenses and refraction. So till here we have finished reflection and mirrors. After this, we are going to start refraction and lenses. So numericals or the problems in exam, whatever it will be asked, it may be from mirror or it may be from lenses. So you have to remember both the things. So I hope you understood this. Please subscribe my channels so that I can prepare more videos for you all and try to like and share my all the videos with your friends. So in this our summary session or this revision session video of light refraction and reflection and refraction, now we are going to move with refraction. So first we will see what is refraction, then we will see laws of refraction. So what is refraction? When the light travels from one medium to another medium, it appears that the direction of propagation of light in the second medium changes. This phenomena is known as refraction of light. So already we have studied reflection, what is reflection, what are the formulas, laws, everything we have completed. And now, as the term says, the refraction. What is refraction? Here the light is going to travel from one medium to another medium. So this medium, it may be a air, it may be a water, it may be a glass, but it should be transparent. Remember, it should be transparent. So when light travel from one medium to another medium, it appears that it is changing its direction of propagation. So whenever we are looking from the outside, and when the light is traveling from one medium to another medium, when the light enters into second medium, it appears to changing its direction. Means in reality it will not change its direction. But when we are looking from outside, it appears that it is changing in direction in the second medium. And that phenomena, that process is called as refraction of light. So I hope you remember reflection. Reflection means what? Whenever the light hits on the surface, this is the surface, this is the light, hits on the surface, it goes back into the same media. That is called as reflection. But in refraction, when the light hits on the, passes in one medium, it hits on the interface, it changes its direction into the second media, and that is called as refraction. So see this diagram, very simple diagram, which explains what is refraction or refraction process. So this is one media. Here I have written water, and this is another media which is I have written water. Air. Imagine you have taken a glass, in that there is a water. So this is water media, this is air media, and this is the light rays which hits on the interface of medium 1 and medium 2. What is interface? It is the boundary between two medium. So whenever the light comes and hits on the interface, on the boundary, that point is called as incident point or point of incident. So here this is our point of incidence. So whenever the light hits on this point of incidence on this interface or the boundary, now the light enters into the second media. But when it is entering into the second media, it is appears that it is changing its direction. Actually, the original direction is here. But how it is appearing when we are looking from the outside, we can see that the light is entering here. It is moving like this. So it has changed its direction. So it appears to change its direction, and that the process is called as refraction. What is this dotted line? Wherever there is a point of incidence, at that point we are going to draw a perpendicular line in both the medium, and this line is called as normal. So remember this. Even in reflection we have studied normal. Even in reflection we have studied incident angle and reflected angle. Here we are going to study incident angle and refraction angle. So remember this. In this formula, in this whole diagram, if you see, this is our incident ray. So I will write it here. This is our incident ray. This is our refracted ray. See, this is refracted ray. As I told, this is normal. This angle is angle of incidence, and this angle is angle of refraction. And this is our normal. So whenever the incident ray hits on the interface, this is the boundary on the interface. This point is called as point of incidence. I will name it as O. So whenever the incident ray hits on O, it enters into the second media, but while entering, it changes its direction. The actual direction is here. This is the actual real direction, but it appears that it is changing its direction, and this process is called as refraction. I hope you understood what is refraction. Now we will move with laws of refraction. Now as we have studied the laws of reflection of light, same way there is a laws of refraction of light. Here also we are going to study two laws. The number one, the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Very simple. same like reflection. So this is our incident ray, this is our refracted ray, this is our normal, which we have drawn on the point of incidence. All will lie in the same plane, means no ray will come out of this plane or out of the screen. If it is coming out of the screen, then we can call it as out of the plane. But now all will lie on the same plane, in the same plane. This is our first law of refraction. Now, the second law of refraction. The ratio of sine of angle of incidence to the sine of angle of refraction is constant. So here also, as I told, we are going to get angle I, angle of incidence, angle R, angle of refraction. If you find the ratio of this, the value will be always constant for the light of a given color and for the given pair of media. So remember, whatever light we are using and whatever media we are using, for that particular medium, for that particular light, the ratio of sine of angle of I to the sine of angle of R will be always constant. This is also known as Snell's law of refraction. This law is also called Snell's law of refraction. And this is true for angle whenever I is greater than 0 and less than 90. Means this I angle should not be 0 or should not be greater than 90. If it is more than 0 till 90, then this law is possible. Here, if I is the angle of incidence and R is the angle of refraction, then what is the ratio? How we can write? We can write like this. Sin I divided by sin R will be always constant. Remember, and this will be true only for a particular light and for a particular pair of media. If we change the light or if we change the medium, then for that the constant will be different. This constant is denoted by the letter small n, and this is called as refractive index of the second medium with respect to the first medium. So whatever value we are going to get, which I told it is a constant for a particular light and a particular medium, that is nothing but a refractive index, which is denoted by the letter small n. And always remember, this refractive index will be of the second medium with respect to the first medium. So these are the laws of refraction which you have to remember. It will be asked many times in the exams, even it will be asked for the test which will be conducted in your schools. So this is laws of refraction. Now we are going to move with the next. Now we will study a little bit extra about this refractive index, or a little bit detail about this refractive index. What this refractive index tells? It tells about the extent of the change in the direction that takes place in a given pair of media and may be expressed in terms of the refractive index, and that is nothing but the constant. So what this refractive index tells? It tells about the extent of change in the direction. So whenever the light enters from one medium to another medium, how much it is going to bend, or how much at what extent it is going to change the direction, it can be explained by using this refractive index. It is related to the relative speed of propagation of light in a different media. So whenever I say the direction changes, it is nothing but that light is changing its speed in that particular medium. And due to the change in the speed of light in that medium, it is changing the direction of the ray in that medium. So the velocity of light changes in different media. We know that the light velocity is more in case of air media. If you compare in the water media, it will be a little bit less. So if you compare in case of solid media, it will be again less compared to the air. So if the velocity of light changes, automatically it will take more time or less time to travel that particular distance. And depending on that, the direction of that light changes in that medium. So if we imagine this is the boundary. Here it is air media and here it is water media. So as I told, in air the velocity of light will be more. So imagine this is the point of incidence, and here this is our normal, which I will draw perpendicular to the medium. So whenever the light ray hits, so this is the light ray which is traveling in air. Once it hit on the interface, it changes its direction like this. So instead of going straight, it is changing the direction, means it is traveling less distance. See, this is the greater, highest, it has to be here. If it is air media, then the distance travel will be more, but it is traveling less distance in water. Why? because the speed of the light will be less in water. So that's why the ray or the light ray is bending towards the normal. Now, if I reverse it, imagine this is water and this is air. Now see what happens. Sorry, AIR, air. This is the point of incidence and imagine this is our normal. Now what happens? In water, imagine this is the light ray which is coming. It hits on the interface, the point of incidence. But when the light ray enters into air, the speed will increase and it covers more distance. So the light ray bends like this and it covers more distance. So it is bending away from the normal. So I hope you're understanding. In case of first diagram, in case of this first diagram, whenever the light is in the air, it is traveling fast to cover more distance. But once it enters into water, the speed decreases and light will bend towards the normal. It covers less distance. But in the second diagram, whenever the light ray is there in water, it travels slowly. But once it enters into the air, speed increases and it tries to cover more distance, so it moves away from the normal. It is nothing but what? The change in direction or extent of bending of this light rays in the second medium, it is depend on the velocity of that light in a particular media or a given media. And always remember, velocity of the light changes in different media. The value of refractive index for a given pair of media depends upon the speed of light in the two media. The same thing which I explained just now. Now, how it changes here? This sentence will help you to remember. Denser medium, lower the speed of light. If the medium is denser, like water, solids compared to air, then the speed will be less, lower the speed of light. If the speed of light is less, refractive index will be high for that medium. And the second one is rare the medium. If the medium is rare, then the speed of the light will increase. If speed of the light increases, then the refractive index will be less or the lower the refractive index. These are the two sentences which you have to remember. So I'll repeat once again. Denser the medium, lower the speed of light, higher the refractive index. Rarer the medium, higher the speed of light, lower the refractive index. Then if I want to find out this refractive index, then N is the refractive index and M is the medium for particular medium, whichever media you will take, air, water, solid, etc. Then speed of a light in air divided by speed of a light in that particular medium. This formula if you use, then we will get the refractive index for that particular medium whichever you are using. If you want to find out the refractive index of glass, then take speed of a light in air divided by speed of a light in glass. Then we will get the refractive index of that glass. If I want to find out the refractive index of water, then take speed of the light in air and then speed of the light in water. We will get the refractive index of water. And like this, we can use this formula for any solutions, any media whichever is transparent. So you know speed of a light, which is denoted by the letter C. So here the value is 3 into 10 to the power minus 8. So that meter per second. So that is the value of speed of the light in air. So that you can substitute here. And speed of the light in medium, depending on the media, you substitute here in place of V. V is nothing but velocity. If you divide this, then you will get the answer of refractive index. So we can remember this value. C value is 3 into 10 to the power 8. Actually, it is not minus 8, it is 8. So remember 3 into 10 to the power 8 meters per second. So it is the speed. So it is the unit is meter per second. And then V value will be depends on the medium. Whichever medium you are using, according to that medium, you substitute the velocity and then we can find out the value of refractive index. I hope you understood this topic which is called as refractive index. The question will be asked, what is refractive index, or write a note on refractive index, or how the refractive index and the velocity of the light in that medium is related. So for that you have to remember this all the explanation. I hope this explanation will help you to understand this topic better. Now after this we are going to move with the lenses, that is convex lens and concave lens, and for that we'll move in the next page. So now we are going to see summary of image formation by concave lens. So convex lens just now we have finished. Now we'll start with concave lens, and as I told, for convex lens we have 6 images, but for concave lens we have only 2 images. So this is the lens which has thinner part at the middle and thicker edges. So remember this, and where the light rays will diverge, also called as diverging lens. So here we are going to keep our object first at infinity and then we are going to keep our object between infinity and the optical center O. So first one, so somewhere here if image our object is present, imagine somewhere here we have our object that is at infinity. Whenever there will be infinity, there will be no connection between the object and these all the rays or these lines. Keep some distance, so it shows that it is at infinity. And whenever object is at infinity, all the light rays will be parallel. Parallel to what? Principal axis. So this is our principal axis. So here what happens? In this case, all the light rays will come parallel, hit the lens, refract, and those all will diverge like this. They all will diverge. And after diverging, these rays will not meet on this side of the lens. So what we are going to do? We are going to extend these all the refracted rays on the other side of the lens, and they will appears to meet on the principal axis at f1. So this is the f1 principal focus on the other side, on the same side of the lens. We can say on the same side of the lens from where these light rays are coming and hitting the lens. So here the image location is what? It is f1. Because it is image forming on the same side, it is virtual and erect, and because directly forming on the principal axis, these all the rays appears to meet on the principal axis, the size is point size, or I can say highly diminished. So this is the first image. So what I can say, whenever the object is at infinity, the location, image location will be at f1, image nature will be virtual and erect, and size will be highly diminished, or I can say point size. Now here I hope you understood this f1, because these lenses will have f1 principal focus on one side, f2 principal focus on the other side. So if I consider this lens, imagine I will consider this convex lens. This is the principal axis. This is our optical center O. This is called as principal focus f1, and this is called as 2f1, or I can say C1, center of curvature. This is the distance which is called as focal length f, and this distance will be same as f, therefore it is written as 2f1. On the other side, this is f2, principal focus f2, and this distance will be same, which is c2, and therefore this I can say as 2f2. And these are the labelings which are remember. These are the points which you have to remember for lenses. Same way there will be for concave lens. So if suppose this is the concave lens, this is the optical center, then this is, if it is f1, then this will be 2f1, or I can say c1. If this is f2, then this will be 2f2, or I can say c2. So remember these labelings, these points, and then it will be easy to remember the image location. Come back to the diagram again. So I told in the first diagram our image is going to form at f1, means this principal focus. Now the second one, we are going to move our object towards the lens. So we are going to keep it between infinity and optical center. So here this is the position of the object. This is the optical center and this is the infinity. So we are going to keep it between these two. So this is our object. The light rays which are going parallel, they will diverge. The light ray which is going to pass from the optical center, it will go straight. And after a refraction, they will appears to meet at A dash. So join this A dash with this principal axis by the perpendicular line. So it will join at B dash. So A dash, B dash, it is our image. So what is the position? If you see here in the diagram, the position is between F1 and O. So I will write position between F1 and optical center O. Because the image is formed on the same side of the lens, we will write it as virtual and erect. And what about the size? Now we are drawing here a perpendicular line, that is A dash B dash. So if you see the size, it is diminished compared to the object. So these are the two diagrams which will form image diagrams which will be formed in case of concave lens. In these two, the second one is very important, which will be asked many of the times in exam. So remember the second diagram. So practice this diagram will be easy, as I told many of the times for in exam, either lens or the rays, one diagram will be asked compulsory. So remember these diagrams. Now, two things which you have to remember is focal length for convex and concave lens. So what is focal length? It is the distance between the optical center and the point where all the refracted rays will meet. So in case of convex lens means this lens, the one which I have drawn here. In case of this convex lens, whatever rays will come parallel to the principal axis, once they hit the lens, they will refract and meet on the other side, and they will meet at f2. And this is the which side? It is the right side. And right side means the distance or the focal length will be shown by positive sign, which we have already studied in our sign convention topic. So in case of concave lens, which we have seen just now, whatever the light rays will come parallel, they will diverge and appears to meet on the same side. So if you see the distance between F1 and O, which is on the left side, it will be always negative. So therefore, focal length for convex lens is always positive. Focal length for concave lens is always negative. So now that is object or image distance, that is h or h dash. Actually, it should not be distance, it should be height. So I will make the correction. Sorry for the inconvenience. So this is height and this also should be height, as we have used the letters h and h dash, because for object and image distance we use u and v. So here object or image height, that is h or h dash, above the principal axis always positive and below the principal axis always negative. So these all we have already discussed in our sign convention in case of mirrors. So sign conventions will be same for mirrors and lenses. So remember, object height, that is h, and image height, that is h dash, above the principal axis. If this is the principal axis, then this is called above the principal axis, which is always positive. And image height and object height, that is h dash and h, below the principal axis, that is down, these all will be always negative. So this is all about the sign conventions of convex lenses. So using these sign conventions, now we are going to see the formulas, how to solve the sums. Now we will see lens formula. Here we are going to study lens formula, magnification and power of lenses. So these are the three formulas which are used in case of lenses, and many of the times in exams sums or the numericals will be asked where we can use these all the three formulas. So first we will start with lens formula. So if question comes what is lens formula, so remember what you have to write: the formula which gives the relation between V, U and F, or the formula which gives the relation between object distance, image distance and focal length is called as lens formula. So what is the formula? 1 by V minus 1 by U is equals to 1 by F. So in exams, V and U, if it is given, you have to find out F. If U and F is given, you have to find out V. Or if V and F is given, you have to find out U. And even with this, sometimes it will be asked what is the nature of the image, what is the position of the image. Sometimes it will be asked to draw the diagram also. So such type of problems will come, or the sums will come on lens formula. So this formula, even the mirror formula, is little bit same, and these letters U, V and F, these all are same as mirror formula. Now the next is magnification. So magnification is denoted by the letter small m, which tells height of the image, or the ratio of height of the image to the height of the object, means how much our image is bigger compared to the height of the object. This will be given by magnification, and therefore the formula will be height of the image divided by height of the object. What is image height? H dash. And what is object height? It is h. So if you find out the ratio of this, we will get magnification. We will understand how much our image is bigger compared to our object. Same formula of magnification we can write in terms of distances, that is V and U. So the formula is M, that is magnification, is equals to H dash divided by H is equals to V divided by U. So such type of formula which is in terms of V and U, that is image distance and object distance, is also used to find out the magnification. Means what happens, sometimes they will not give the height of the image and object, but you will be having the distance between the image and the object. So by using these distances also we can find out magnifications. So this is about magnification of lenses. And now the one more different point, that is power of lenses. So this is the topic which is present only in lenses, that is denoted by capital P. It is nothing but the degree of convergence or divergence of light rays achieved by the lens is expressed in terms of power. So how much is the convergence, the degree of convergence, or how much is the divergence, that is degree of divergence? It is nothing but power, and which is denoted by the letter capital P. So what is the formula for this? The formula is P is equals to 1 by F. F means focal length. Focal length, it is the distance between the optical center and the principal focus. And what is principal focus? It is the point where the light rays after refraction meets. So that point is going to decide the degree of convergence and the degree of divergence. Therefore, we are using focal length in this formula to find out the power. So here this formula also we can change. Also sometimes we can write like this: if we want to find out focal length and if we have power, then we can write F is equals to 1 by P. So both the ways the formula can be used depending on the sum or the numerical which is asked in exam. Now always remember, for convex lenses focal length is positive, then power should be always positive. For concave lens, focal length is negative, then the power should be negative. Always remember this, because focal length is there in the formula. So whatever is the sign for focal length, that will be the sign for power. So for convex lens, focal length is positive, then the power should be positive. For concave lens, focal length is negative, then the power will be negative. So this is about power of lens. The SI unit of power of lens is dioptry. So this is the SI unit, standard unit for measuring power, and which is denoted by the letter capital D. If F is expressed in meters, focal length is measured in meters, 2 meter, 3 meter, 4 meter, like this. So it is a distance, no? So distance is always measured in meters. So if F is measured in meters, so remember it is 1 by F. The formula of power is 1 by F. It is nothing but 1 by meter. Then the power is expressed in dioptries. Thus, 1 dioptry is the power of lens whose focal length is 1 meter. So what is the meaning of this? 1 dioptry is equals to 1 per meter, because if it is 1 by F and F should be F is in meter, then the meter, if it goes up, then it will be per meter. Then therefore always remember 1 dioptry, it is nothing but 1 per meter. So this is all about power of. So students, here we have completed all the topics which are important from this chapter, which is called as light, reflection and refraction, which all are important for the exams. And as I told, the detailed video of this I am going to prepare once again separately for you all. So I hope these all the content will help you for the preparation of the exams, for your final exams. So students, for more such videos, like my videos, comment the doubts which you have from any chapter, Science SSLC, share my videos with all your friends, and please consider subscribing in my channel so that I will get motivated to prepare more and more videos for you all. Thank you. Thank you so much.